In this video, we will discuss Bernoulli differential equations. So what are Bernoulli differential equations? These are differential equations which is in the form, just write it down, y prime plus p of xy is equal to q of x times y raised to n. Now in the previous video, we have discussed linear differential equations, and the difference is, for linear differential equation, the standard form is just this one. There is no y raised to n, and we have discussed how to solve the integrating factor and how to solve linear differential equations. So we're now in the case wherein we have an extra factor here, which is y raised to n. Okay, so what will we do if we encounter Bernoulli differential equations, or simply Bernoulli equations? Okay, so we have y prime plus p of xy is equal to q of x y raised to n. So first step is we will multiply y raised to negative n. So I will now have y raised to negative n y prime plus p of x times y raised to 1 minus n, and then is equal to q of x. Notice that if I will introduce another variable which is z, no? And let's say z is equal to y raised to 1 minus n. So I will change the variable y to z. Okay, so for that matter, I should get the differential of z. So get the differential of y here, raised to 1 minus n. So 1 minus n times the quantity 1 minus n times the quantity. So this will become 1 minus n minus 1, and then differential y. Okay, so if we will simplify that, this will be 1 minus n y raised to, so you can see that 1 will be cancelled, so raised to negative n differential y. Okay, so if I will go ahead, I will go ahead and substitute that to this one, okay, and also change your y variable to z. What will now be my resulting differential equation? Okay, so let's go to the next page. So let's just write everything down first. We have y raised to negative n y prime plus p of x times y raised to 1 minus n is equal to q of x. And then my substitution, the ones that I chose to substitute is z is equal to 1 minus n, and we also have differential z is equal to 1 minus n raised to y raised to negative n times differential y. Okay, so look here closely, Look here closely. So y raised to negative n, and then we have y prime. So let's just first put this into the differential form. Okay, y raised to n differential y plus p of x y raised to 1 minus n differential x is equal to q of x differential x. Okay, so as you can see here, y raised to n times differential y can be differential z over 1 minus n. Okay, so then plus y raised to 1 minus n is z, so p of x times z differential x is equal to q of x dx. Okay, so what do we now have here? This is already a linear differential equation. Okay, so just to formalize that it is a linear differential equation, we can multiply 1 minus n to both sides of our equation, and we will have differential z plus 1 minus n p of x z differential x is equal to 1 minus n q of x dx. Okay? So this is now a linear differential equation, and it's linear in z. And our integrating factor will now be e raised to the integral of 1 minus n integral of p of x dx. And you can just go ahead and proceed with the steps in solving for a linear differential equation. Okay? But after the solution, we have to just return the variable to y. So from z, you have to return it to the variable y. Okay?